All right, so special triangles right here. So this triangle has a 60 and a 90. What we don't know here is this is a 30 right here. So we can fill that in. All right. Now remember your little cheats. We always want to go to the short side first if we can. Okay. So the short side is always going to be opposite the smallest angle. So V right here is the shortest side. So if you remember, if you use your notes, the way we go from the hypotenuse to the short side is just divide by 2. So from here to here, we're going to divide by 2 and get 8. And then we go to the long side, which is opposite, well, not the longest side, but the longest leg, which is opposite the 60. And if you remember, we're going from there to here. We're going to multiply it by root 3. So that's going to simply be 8 radical 3. On number 2, notice that we have a 45, 45, 90. The legs are the same. Okay, so that's easy for n. We know the legs are the same, so that's 4. And then when we go from a leg to hypotenuse, we're going to multiply by radical 2. So that's 4 radical 2. Okay, so once again, you should have this in your notes. So the short side is x. The hypotenuse, which is opposite the right angle, is always 2x. And this is x times root 3. All right. And then for 45, 45, 90, again, the legs match. So this is x, and this is x times root 2. Another way to remember this is 45, 45, 90 has 2 different numbers, so it's radical 2. 30, 60, 90 has 3 numbers, so it's radical 3. But you should have this in your notes just as a guide. All right, number 3. So this is a 45, 45, 90 again. So this time we have the hypotenuse. So when we go to the legs, which are going to match, we're going to do divide by radical 2. Now remember, when we have to divide by radical 2, this is when we need to rationalize. So we're going to multiply the bottom by radical 2 to get rid of it. Therefore, we do the top by radical 2. So that's going to give us 10 radical 2 over, remember, radical 2 times radical 2 is simply 2. And then we can always look to reduce, if possible. 2 goes into 10 5 times. So that's 5 radical 2 for each leg. All right, number 4 is a 45, 45, 90 again. So the legs match. That's easiest right here. Now this was kind of a trick one, but not really. It's an easy trick. When you go from the leg to the hypotenuse, you multiply by radical 2. So like we just did on the previous problem, radical 2 times radical 2 is simply 2. Technically it's radical 4, but square root of 4 is 2. Number 5, we have a 30, 60, 90. This time we're given the longer leg. We always want to get to the short leg, okay? So for the short leg, we need to go and divide this time by radical 3. Well, off to the side, if you do 5 radical 3, divide by radical 3, what happens to these? They cancel, meaning this is 5. And then going from the short leg to the hypotenuse, we simply are going to multiply by 2. So that's going to be 10. Okay, number 6. Again, looks hard, but it's really kind of easy. Remember, when we go from the hypotenuse to the leg, we divide by radical 2. Therefore, if I do 8 radical 2 divided by radical 2, these cancel, leaving me simply 8. And the legs match on a 45, 45, 90. All right, we have a 45, 45, 90 again. Okay, the legs are going to match. So 5 root 2 and 5 root 2. Remember, we get bigger going to hypotenuse because it's the longest side. We're going to multiply by radical 2. So down here, we're going to do a little bit of work. 5 radical 2 times radical 2. Remember, this is 5 times radical 2 times another radical 2. Radical 2 times radical 2, we've talked about already before, is simply 2. Which means we get 10, so the hypotenuse of this is 10. Number 8 is kind of easy because we have the short side here. And that's always makes it easier if we have the short side. So going to the hypotenuse, you can go either way first, but I'll do the hypotenuse first. I'm just going to multiply by 2, which gives me 4. And then going to the longer leg, we multiply by radical 3. So that's simply 2 radical 3. That's all you have to do. All right, 45, 45, 90 again. The legs must match. And this one's really easy because all we do is multiply by radical 2, 6 radical 2, and we're done. That's all we had to do. Number 10 is a little more challenging because this time we have the hypotenuse and we have to divide by radical 2, which means we're going to have to rationalize. So 2 divided by radical 2, just like before, we're going to multiply by radical 2 here and on the top here. On the top, that's going to give us just simply 2 radical 2. On the bottom, radical 2 times radical 2 is just 2. The 2's are going to cancel, and we're going to have radical 2 and radical 2. Okay, find the missing side. Round to the nearest tenth. So this is where we're doing the Pythagorean theorem. And remember, it's always important to find the hypotenuse and label it C. Even if there's a letter there like X, we're going to label it C. And it doesn't hurt to go through and do this first. So you always remember where C is. Because, remember, a squared plus b squared equals c squared. You can write this every time or at least just up at the top. Now think about it. On this one, we have c. So make sure you put the 15.6 here. Okay? A lot of people want to do 11.1 squared plus 15.6 squared, but we have c. It doesn't matter which one is a or b up here. So I'm just going to put x squared plus 11.1 squared. If you want to put a squared plus 11.1 squared, it doesn't really matter. Okay? So now we just type in our calculator. Okay? We're going to type in 11.1 squared. And my calculator went missing. Where's my calculator? Okay, hold on. All right. So 11.1 squared is 123.21. So x squared plus 123.21 equals 15.6 squared, which is 243.36. Now remember, it says round to the nearest tenth, but we're going to round at the very end. So now we're going to subtract, we're trying to get x squared by itself, 0.21 minus 123.21. And that gives me x squared equals 120.15. And now we're going to square root both sides. So the square root of 120.15 is 10.96. So this one's a tricky one because we're going to look here and round this 9 up to 11. But I would still put 11.0 just to say that it wasn't exactly 11. Because it wasn't 121, it was 10.96 and 120.15. So putting the 0.0 lets you know that it was not a perfect number. Okay, that still lets you know that it's 9 rounded up. All right, so this one, we do know A and B, so we're going to put 7.8 squared plus 4.2 squared equals C squared or X squared, whatever you want to put. So 7.8 squared is 60.84. And we're going to save the rounding for the end. 4.2 squared is 17.64. We're going to add those together and get 78.48. Now that's C squared, but we want C. So we're going to square root both sides. The square root of 78.48 is 8.85. This 5 is going to round that up to 9. So this is 8.9. I forgot to put 11.0 here. All right, and keep going. So notice we have C. So this time I'm going to make this A. I'm going to put B. If you want to put X, it doesn't matter. And then 13.3 squared. So 6.7 squared is 44.89. Plus B squared equals 13.3 squared is 176.89, which means I need to subtract 44.89 and this is going to give me B squared equals 132. And now we're going to square root both sides. So the square root of 132 is 11.48. This 8, again, is going to round that up to 11.5. So this leg here is 11.5. And again, that makes sense because it's less than the hypotenuse, the longest side. 24, we're missing C again. Okay, so we're going to say 12.2 squared plus 13.8 squared equals C squared. So 12.2 squared is 148.84. 13.8 squared is 190.44. We're going to add those together and get 339.28. But again, that's C squared, so we're going to square root both sides. So the square root of 339.28 is 18.41. Finally, we get one that rounds down, which means the 4 is going to stay the same, 18.4. Does my answer make sense? Yes, because that is bigger than the 2 legs, and it must be. Okay, I just noticed, I don't know why. These are numbered weird. 1 through 4, 5 through 8, 21. Wow. I don't know why the pages are out of order, but we'll just keep going. Okay, number 11. We're back to 30, 60, 90 triangles because, again, out of order. So this is 30. Right there. So what do we have? We have the long side, 6. So we need to go from the long side to the short side. We always go to the first side if we don't have it already. So remember, to do that, we divide by radical 3. So it's going to be a little bit of work. 6 divided by radical 3. We must rationalize, like so. Okay? So that gives me 6 radical 3 over 3, which is going to simplify to 2. So this is simply 2 radical 3. And then, going to the hypotenuse, we just double it. And remember, we only double the outside number. So that's going to be 4 radical 3. All right, we have the hypotenuse here. So we always go to the short side. Where's the short side? Opposite the 30-degree angle. So we're going to go over here and divide by 2. So 4 radical 3 divided by 2 is 2 radical 3. This one should look familiar. Look at number 11. And then going to the longer side, we're going to do 2 radical 3 times radical 3, which is going to be 2 times 3 because the radicals cancel, and that's 6. So 11 and 12 are the same problem, just working backwards. Okay, 13. So what do we have? Here's 30, 60. So that's the long side. We want to go to the short leg. So we're going to divide by radical 3. Well, that one's pretty easy because radical 3 divided by radical 3, anything divided by itself, we can't just say canceled because then there's nothing there. Anything divided by itself equals 1. So that's 1. And then quite simply, here you double it. So 1 times 2 is 2. All right, 14, we have a 45, 45, 90 again. We're going from the long side to the leg, which means we're getting smaller, so we're dividing by radical 2. So we simply write 8 divided by radical 2, and then we rationalize like we've been doing. So that's going to give me 8 radical 2 over 2. 2 goes into 8 4 times. That means each leg is 4 radical 2 because they must match because the legs are the same on a 45, 45, 90. Okay, number 15, we have a 45, 45, 90. So this leg over here is easy because it must be the same thing as the other leg. And going to the longest side, we simply take 4 radical 2 times radical 2, which means the radicals cancel, and 4 times 2 is 8, and that's it. Now, number 16 is going to be rather similar to number 11 because we have the long side. So we're going to go to the short side first by dividing by radical 3. So this one's the nastiest one of the bunch because nothing's going to cancel. You know, in number 11, the 6 and the 3 canceled, and we had nothing on the bottom, no denominator. But this one's going to be a little bit more work. So we have 10 divided by radical 3, which we must rationalize. So on the top, we get 10 radical 3. And on the bottom, we get 3, which does not go into 10. So that is our messy kind of answer for the other leg. 10 radical 3 over 3. Now remember, this one's easy, but it's complicated because all you do is double this. But what do you double? You only double the outside number in the numerator. So that's going to be 2 times 10 is 20, radical 3 over 3. Done, stop, don't do any more. And that's the nastiest one on there. All right, number 17. Again, we have a 45, 45, 90. The legs must match, so this is 5. And then all we do is multiply by radical 2. And that simply means just stick the radical 2 onto the 5. And then here we have 30. So that's our small side. So going to the hypotenuse, we just double it. And going to the longer side, we multiply by radical 3. And that's it. Number 19. We have the long side. So going to the short side, we must divide by radical 3. This one's actually easier than it looks because the radicals are going to cancel out like on an earlier problem. So that means this is simply 3. And then going to the hypotenuse, we simply double it. 6. All right, this time we have the hypotenuse. Haven't had one of those. So always go to the short side first to make your life easier. So we're going to go to the short side first, which is opposite the 30. And all we do is divide by 2. So that's 9. Then we go to the longer leg, which is multiplied by radical 3. And that means just tack it on there. That's all you have to do. And there's your answers. And there's the bell ending it.